Here we have an iPhone 6 that came in for data recovery, and this one came in locally. Customer said that he needs data because nobody fixes an iPhone 6 just for the sake of fixing an iPhone 6. You can go online and buy a used one for how much? $60, $70. I have not checked the past couple of years. I do not know how much those phones are going for, but they're pretty cheap. I told the customer I'll do my best, and we already disassembled the board. The customer mentioned one thing. He said that about a year ago, he went to another shop, they replaced his battery, and the battery has been working for the past year. So battery likely has nothing to do with why the phone is not powering on right now. Now, I already started working on this board, and then I thought, why not record the video? Let me show you what was done. If you notice here, I removed the plate that was soldered on this side of the board, and the plate looks something like this. And I also removed a piece of black cloth that sits on top here that covers the touch IC, so on and so forth. And I also desoldered a plate that covers the CPU right here. You can tell. So we did three things. Now what I want to do is plug in the charger, and we're going to plug in the battery. Are we using the right one? This one is 6 Plus. That's the wrong one. Before we proceed with this video, I want to give a shout out to our sponsor, PCBWay. PCBWay is a PCB manufacturer and printed circuit board assembler with more than a decade in the field of PCB prototype and fabrication. This month, PCBWay is holding a competition where a user submits their PCB design for a chance to win $1,500 cash plus $200 in coupons that can be used on the PCBWay website. If you have a good PCB idea, click on the link below to sign up and make sure to check them out. And I'm using the mechanic power supply. This device has been out of stock for the past maybe a month or two. We have them in stock right now. And the device supports up to, I believe, iPhone 13 Pro Max. Let me show you how it looks like. Device looks something like this. The cable is short, so I'm not going to be able to go all the way up to show you. We have the charging connector and the battery connected to the board using this extension cable that is supplied along with this device. And I just want to show you what happens when I plug in the cable. Display goes off. The display went off because of likely a short circuit on the board. We should see an amp draw on the screen here. We should see 0.3, 0.4, 0.5. It should go up to about 1.4 amps and then back down to about 0.4 amps if that board is working. But as soon as I plug in the cable, the device goes off. Let's unplug. And we're going to unplug the cable. We do have that device in stock as of today. If you are a hobbyist or in the same type of business, you can purchase that device off our site. We do have it out of stock as of current, but we should update the status maybe by later today or tomorrow. And you can buy everything that you need all from one place. We have soldering stations, hot air stations, thermal camera, power supply, Flux, tweezers, voltage injection tool, the amazing microscope that we use, which is the best out there, the anti-glare light. All items are in stock. The only thing we have out of stock as of today is the microscope articulating arm. You can either wait until we get them back in stock, or you can get the one from Amscope. So right now, since the meter is going off, as soon as we plug in the charging cable and battery, it tells me that we have a short circuit. And that was the reason why I desoldered that plate from here. We removed that black piece from here, and we also desoldered the plate from here. The first thing I want to do is check for a VCC short. Let's open up the board diagram. Now all the red dots that you see on the front and back side of the board are points where we can test for VCC. I want to test to see if we have a short circuit on any one of those red dots. So the bottom part is back of the board and the top part is front of the board. Now since I have the board flipped to the back, that's the front and that's the back, let's start with the back. From my experience working on iPhone 6s, I know that we have a VCC point right here. If we check the board diagram, if you read down on the bottom, PP, VCC main. So I want to test and see, do we have a short circuit here? I can also test the capacitor that's on bottom of the chip. This point right here. I can test the cap that's on top. Let me show you what I mean. Red probe on ground, meter in diode mode. We're gonna put a probe here, and I can measure right here. And look at this, we have a short circuit. If we go to ohms mode and we test here, 0 ohm. 0 ohm reading. So we do have it that short on the VCC line. Let me go back to diode mode. We can measure here. We have a short. Based on the board view diagram I'm looking at, we can measure here. We have a short. So where is the short coming from? Is it coming from this cap? Is it coming from this cap? Is it coming from this cap? Or is it coming from any one of the components on the board that connects directly to VCC? We do not know. We cannot just remove components until we get to the component that is causing the problem. We cannot do that. The chip itself may also be causing the short. If you look at the board view diagram, let me show you. This is back of the board. Let me zoom out. You can tell that a lot of components on the board connect with VCC main, and any one of those components could be the culprit. Look, if you go to the touch area right here, we have more components here that connect to VCC, and those are caps, because one end is ground and the other end is VCC. You have more caps here. Any one of those could be causing the short. And then if we flip the board, go to front of the board, same thing. We do not have as many components that connect to VCC as back of the board, but we do have a cap here that could be short into ground. We could have a component here that could be short into ground. If that component is a capacitor, of course, resistors do not short to ground. We have an inductor here. Inductor does not short to ground. It's something that causes the inductor to short to ground, likely a capacitor or an IC. And we also have VCC right here. And this one is a cap. Right now what we can do is we can inject voltage on any one of the red dots that you see on back of the board or front of the board. And we can monitor the board under a thermal camera and see what gets hot. We want to narrow down where that short is coming from. Let's go ahead and do it. I'm going to set my voltage injection tool to 1.4 volts. If I do not see anything at 1.4, then maybe we can bump up voltage. So I currently set the NF.short voltage injection tool to 1.4 volts. And I'm going to connect the ground alligator clip to one of the ground pads on the board, the screw hole right here. And now we can inject voltage and see what gets hot on the board. So look at this. I see something hot right over here. Right there. What's here? Let's take a look. You see? We got it quick. We injected voltage and something got hot on the bottom side of the board. So if you look at the board here, let me disconnect. I injected voltage right on this side of the board, right at the cap over the chip, and something got hot right next to the touch IC. Let's take a look at the board and see what's in this area. And we can also look at the board diagram and see what VCC components are in this area. So we got a heat spot right over here. Based on my experience working on iPhone 6s, it's almost always never this IC that is causing the short. We do have two caps here connecting to VCC right below the touch IC. But again, from experience, I never seen those caps go short. And the heat spot was coming all the way from the edge. From this edge right here. We do not have any components right on the edge that connects to VCC main. So what I want to do is let's take a look at the front side of the board. Flip the board. And if we flip the board, the area that got hot from back of the board is right here, right at the top, where you see this big inductor. Let me zoom in. So the heat spot is coming from right over here. Right here. We see a huge inductor, and this inductor does not short to ground. Inductors and resistors do not short to ground. If I am to take an educated guess, I would go for this component or this component. Those are big caps, and those caps can cause a short circuit. And I've seen it happen before. I'm using a combination of logic and experience. we have two caps right here, and one of them could be causing the short. Which one? Let's wait until the board cools down a bit. Maybe we can inject voltage at any one of those two caps and we can apply isopropyl and see where alcohol boils first or evaporates first. But the board is hot right now because we applied a tiny bit of hot air to scrape off the overfill. So we're gonna inject voltage at any one of the two caps from the bottom. And let me grab some isopropyl. Or we can inject voltage right here, and then we can apply alcohol isopropyl. Let's do it. I'm not able to tell. Unless the short is not coming from here. It looks like it may be number one. Watch how alcohol is not staying on that cap. Okay, I think we got it. This guy right here. Just flick off that cap, meter in diode mode, and let's measure right here. Wow, no short. Wow, we did it. We do not have a short anymore. Let's flip the board. Go back here. See what we did? We used logic and prior experience working on this board. We took an educated guess and we got it. We do not have to replace the cap. We'll do data recovery and we're done. Let's measure here. No short anymore. No short anymore. And no short anymore. That was an amazing repair. Wow. But let's not consider the repair done yet until we see the Apple logo, foam boots, and then I'll call it a repair. I'll be back. Big Boss just informed me of the good news. Look at this. Wow. The phone is working. And the cap that we removed, and you're not going to be able to see it, but the cap that we removed was right over here. See how we have one cap left? Wow. Wow, amazing. Amazing. We did it. We're going to start the backup process, and then we can call the customer to come and pick up. I hope you enjoyed the video. Thank you, Big Boss, boss of all bosses. Don't forget to like and subscribe, and we'll do something else in the next video.